Ms. Sherrine Eid is the Global Head of Epidemiology, RWE, and Observational Research and Data Ethics Ambassador at SAS, uh, driving ethical and responsible innovation. Sherrine Eid has over 20 years of experience in real-world evidence, epidemiology, and biostatistics. Her passion for better public health led her to work for USAID, CDC, and other donors in global health development, focusing on reproductive health and family planning and infectious diseases. Her current focus is supporting regulatory, safety, late phase, and post marketing activities across therapeutic areas using clinical and real world data to glean real world insights. So that's all for the introduction for Ms. Sherrine. And Ms. Sherrine, you can feel free to kind of start your presentation. Thank you very much.
Great. Thank you very much for having me today. It's very exciting to be able to talk about this topic. It's something that I'm very passionate about. We're going to do a quick little exercise. So on our first slide, but I'm going to talk about implementing trustworthy AI. We talked about the importance of it, but really, how can we do it, right? So we talk about it, and now I want to be able to practically to implement it. So now let's quickly, can you find the differences between these two pictures?
I don't find, but audience, you can put it on the chat. Yeah. Or seems kind of similar to me.
The sky.
Right, the sky. What else?
The boat color.
Okay.
Red versus something.
Uh-huh.
There is a boat on the right in the second one.
Mm-hmm.
But not in there in the first one. Well, I'll let other people to say.
There is an extra boat on the left side of the picture.
Yes, there's a buoy here.
And there is another boat also if you go far away up.
Uh-huh. Yep.
If you go and right next to it.
Yep. Right here.
Yeah.
Okay, very good. Well, most of you got almost all of them. And you are correct, right? There was a buoy missing, there's a boat missing, there's an extra buoy there, there's two extra sailboats. The boat color is different as well as the clouds in the sky, right? One had no clouds, the other one had clouds, right? And we actually, by the way, have been products of AI and doctored images for decades now. This is not something new. It's just happening fast, right? And so what I want you to come into this mindset is we're not in a completely green space right now. We actually have abilities to quantify these biases, to quantify these errors, to address what has been changed and what might be missing. Now it's just happening at a larger scale and faster. So it's not like we are kind of like getting the rug swept from under us. And I'm going to focus on the implementation, but first I want to go over some real world evidence things. How many here, with the show of hands, using your reactions on the Zoom, can have actually worked with real world evidence or electronic medical records or electronic or real world data? How many have mined registry data or claims data? Okay, so, and how many of you are directly involved with direct patient care or working with patients and collecting their data somehow? All right, so in the life sciences space, there are things called real world data. These are the non-randomized clinical trial data, right? So if there's a registry, how many of you have gone to the doctor, right? And your doctor turns around and starts typing away at their computer, they're entering your data and your information into an EMR. So this affects all of us personally as well as professionally. And so some of these data that are not primarily collected for these kinds of analyses, for example, it's a secondary analysis of that data, are actually some of these activities actually result in life sciences in these ways, right? They might do a post-authorization safety study or a drug utilization study. How many patients actually use the drug for how it was intended and what the label says, and external control arms and patient recruitment and things like that. So these are some examples of real world data, which, by the way, all of you have. You have somehow, somewhere filled out a survey about something, or you have an electronic data record or medical claim or a medical record. You have labs, or you've had a prescription filled, even if it was for an antibiotic. You are in some kind of registry sometimes, right? And you may have had a caregiver outcomes assessment. And you can also have had some safety data, like maybe you took a drug and it didn't work, or it worked differently than it was intended. You might know somebody who's passed away. They are in a mortality data set, and you might have had some kind of digital exhaust. Anybody here not have a smartphone? Right? So if you have a smartphone, you have some kind of digital exhaust that we can use these data to kind of gain some insights either into your behavior, your mental health, your activities, or your actual data. For example, if you have a continuous glucose monitor, or you know somebody who does, right? That little patch on their arm actually will connect to their phone, and then through that phone will deliver the data to their provider. And so we're used to having data around now, right? We might actually have become nose blind, if you will, or data blind, not understanding where or what, or not being aware of what data is being collected on us on any given time, nor what is being done with that data, right? If it's just a surveillance versus an analysis, or actually maybe a claim on a particular drug product. But these data are definitely not perfect, because these are secondary uses of data. AI loves to use a secondary use of data, right? All of the chat GPTs, the Dollies, all of the LLMs that are out there now are going through a corpus of data that is a secondary or maybe even tertiary or quaternary use of that data. And so that's why because we don't have that direct purpose and influence on why that algorithm is being run, nor why the data is being collected that's being fed into that algorithm, it's where some of the trustworthiness might erode, or there might be some oops or mistakes that we weren't really aware of, or there could be some malintent where that it was actually doctored, like that picture. So let's look at some data gaps and challenges in these kinds of data, because in the medical setting, these are the data that we commonly use, right? In the EMR, right, you might have some regional regulations. For example, the EU is very different than India, that is very different than the US, that's very different than Japan. And those regulations on what you can and cannot do with that data, where it can go and where it can't go, actually might limit your ability to run any kind of true analytics or understand or properly interpret the results based on that data. You have missing data elements. Anybody who's worked with EMR data knows that, yes, there might be a BMI field that is calculated, right? But we don't know for sure if it was calculated properly. There's no validation involved. We don't know sometimes if somebody's died, especially if they didn't die in a hospital, but they died outside. The discharge destination does no longer says expired or hospice, right? And smoking status. Some patients might self-report smoking status. We don't really know if that's really the case. You have limited validations. You have ordered prescriptions, but not necessarily filled prescriptions. And so this is kind of where the nuance is, where these proxies and how we can actually interpret these data, and where the limitations of these data are. We also have inpatient versus outpatient, and those data sets are usually collected in different ways and in different EMRs. They might be linked if you're lucky enough to be in an integrated data health delivery network, but many times we're not. We're going to independent physicians or independent networks. The previous speakers talked about or shared, what if somebody's in 3 different EMRs? I know for a fact that I'm in 4 different EMRs, that they don't talk to each other. Some of them, even though 2 of them are Epic, but they haven't done any data sharing right now. And then there can be inconsistent diagnoses. When I was working on a migraine drug for chronic migraines, my patients in the claims databases had migraine, episodic migraine, chronic migraine, and headache. And actually, 80% of them were only just headache. Now, if I'm a drug manufacturer, guess what? You can't just use it for headache. My drug would have to be a chronic migraine, and I'd have to show you which CPT code you had, right? And then that will delay, if it's not documented properly through the process, delay the patient actually accessing the drugs. In the claim side, right, you have prescription claims versus diagnostic claims and medical claims. They don't always talk to each other, and they're not always linked because it might be done through a PBM and then an insurance provider that are not affiliated with one another. It can or cannot be linked to the EMR. I might have a fuller picture of a patient. It's billing based, so whatever I can bill for is what I'm going to actually put on that CPT code. And working for Lehigh Valley Health Network and other networks like that, I learned very quickly that the coders are trained to look through the EMR and find what we can possibly code for that may or may not necessarily be part of the actual reason for the visit that moment. It's limited validation. I don't know that I can validate what that diagnosis was or what was entered. So these data come off as very dirty. It's a filled prescription, but even though you filled your prescription, did you take the pill? And then there's governance issues, right? Who's actually overseeing these data, and how are they doing it and for what purpose? Are they actually governing these data in a way that allows it to be evidence submission for regulatory purposes? And does it suffice? Or are we finding a lot of gaps? And then changes in providers, right? If I switch my provider, which I know personally I've done, how does that impact my journey? If you're trying to look at my data and look at the patient journey and say, I'm going to intervene here, do you have a full picture of every patient that you're trying to help? Overall, in registries, we know that there can be incomplete data. There's variable differences. There's not a standardization across all registries. There's limited follow-up. And then there's, again, the governance issue. And then overall with real-world data, right, or the data that we use in general, okay, it's inadequately documented in that change of medical status. If you're trying to do progression-free survival, for example, that's your endpoint. For an oncology patient, how are you calculating it, and how are we capturing it, and how are you trying to derive the data that you do have and the information that you do have to fit a structured data table? You have inconsistent visits and documentation. For example, I don't go to my doctor every 3 months like my condition provides me. And maybe I go every 6 months, maybe I'll go every 4 months, depending on my availability. And unstructured data capture of key elements is a limitation because not everybody has NLP technology that's smart enough to actually determine what is actually captured in those patient notes. And then you have limited patient-reported outcomes, as well as undocumented and fragmented changes in response to your prescription. If I have a safety concern, it might not be in my EMR, or it might be in a miscellaneous set of notes that is uneasily founded. Okay, so that's data gaps and challenges in these data. And then there's process challenges. Do the data talk to each other? Can I link the data? If there are Part 11 regulations, because this is going to be regulatory facing, say in the FDA, right? Am I GXP compliant? Am I working on a validated environment? Am I observing the regional regulations like HIPAA, like GDPR? Is there an audit of secondary data sources? And if there is, how do I apply it? How do I actually implement it? Can I get down to my informed consent, the system access, and the records? And at SAS, we believe in the implementation of this, right? And so data access engines and connectors, the FHIR adapter is something that we already have. We have data access with Management Suite, right? And so I can go through my data quality and assess and get a profile of my data. I can track my records and with the patient data with an audit trail in LSAF. And I can use the data information catalog to look for privacy issues or concerns, and use AI to determine what kind of field, for example, name might be or age might be. And am I too close if there's a combination of age and and gender and race in a very remote part of the country, like the previous speaker shared, can I easily re-identify them? And is there a concern there? And then also looking at encryption, lineage, and fraud, waste, and abuse solutions and technology, where I'm looking for anomaly detection, and then using probabilistic methods. I need that band, right? So when COVID happened, for example, and we were trying to model COVID, SAS was very integral about finding what that band would be when we were trying to model. So not only what is the band, because it's a differential equation, but what's the plus or minus? Now, that's just a use case, right? Which we're very familiar with. We use these data in and out, either to support our direct patient care, to identify some kind of anomaly detection or association within a patient population based on their exposure or what symptoms and risk factors they have. But there's ethical considerations in general when we're doing research that we want to be able to identify that are fundamental to analytics, but then exponentially important in AI, because AI does it faster and it's automated. So the federal policy here in the United States has some tenets, right? And some of the tenets are, for example, there's a data ethics tenets in the federal data strategy around ethical AI and ethical data capture. One of them is to uphold applicable statutes, regulations, professional practices, and ethical standards. We're not going to get rid of HIPAA, for example. We're not going to get rid of GDPR, right? And so therefore, these laws that are already established means that they're important to the population, and we're going to uphold them. The next is to respect the public, individuals, and communities. Just because the federal government has access to all of these data does not mean that they are allowed to take action without respecting the public, the individuals, and the communication and the communities. So there's, yes, we want to benefit the public good, but responsible use of data begins with careful consideration of the potential impacts of these data. And again, these are federal tenants, right? So this is where the federal government has said anytime we are going to allow or consider data, whether the federal government is using it or a private entity is using it, but they're going to be under regulatory scrutiny in a court of law, how are we upholding these tenets and these basic principles? Respect privacy and confidentiality. I should not be able to easily re-identify a patient. I should not always think that I can own these data, right? The previous speaker spoke about, patients wanting to own their data. There's a gentleman, Dr. Christopher Boone, if you're familiar with him, he calls himself the data hippie. He's been talking about data regulation and data ownership within the patient population for years now, before AI ever really got the leverage this information. Sorry, you can leverage this information for dialogues that you want to be part of, right? And so how do I ensure that I can respect the privacy and the confidentiality of a patient, right, in a way that gives them autonomy and ownership, but also allows them to be inspired to contribute to the corpus and to the lexicon of what we're trying to assess for the public good, right? Because they are part of the public. And it's a very delicate balance between individual and society here when it comes to the rights and the obligations. The fourth thing here is acting with honesty and integrity and humility. So I'm going to read verbatim what that tenet says. All federal leaders and data users are expected to exhibit honesty and integrity in their work with data, regardless of job title, role, or data responsibilities. By the way, this should not be limited to federal leaders and data users. This is applicable to all of us who are using data. And so you shouldn't perform or condone unethical data behaviors. And when sharing data and findings, personnel should report information accurately and present any data limitations, known biases, and methods of analysis that apply. This is scientific dissemination 101. And in the chat, feel free to disagree with me. But this is what we've been trained on as scientists in the past, right? And that users are expected to have humility when presenting the data, to be open to feedback as a true scientist, and when possible, invite discussion with the public, right? In addition, users should accurately represent their abilities when working with the data, right? Again, you're establishing credibility so that you can have an objective conversation and focus on what's the good here. Also, recognize maybe I missed something, that you should be able to have a non-retaliatory, non-fearful conversation with me as a trusted steward to say, hey, there's some things here that we want to be able to address, right? And then holding oneself accountable and others accountable. What happens if there is a mistake, whether it's deliberate and intentional or unintentional, and then promote transparency, right? And how can I possibly make sure that with ease of access, there's a true interpretability, that there's important understandings here that we walk away with, that we understand that our work is never done. Just because I know this today doesn't mean that it's true an hour from now, especially with we're seeing this every day now, almost on a daily basis, what could happen and how it could be impacted, right? And so what you know today might not necessarily be hold true for tomorrow. There's benefits that the federal government actually decided to document, right? And that includes consistency, better data-driven decisions, risk mitigation, increased transparency, consideration of wider perspectives, and improved public trust. The federal government understands that when they design policy, when they're actually implementing their activities, that these tenets of the ethics that they had, right, are important to be able to be leveraged, and there are benefits. So if anybody wants to say, well, no, it's not going to be as efficient as, no, there are benefits by holding these tenets true. Now at SAS, we have some principles that we are very beholden to, right? And that we focus on in our software development, and especially the analytics platform, that there's human centricity, that there's inclusivity, that there's accountability, and that there's transparency, privacy and accuracy, robustness, and robustness. And all of these include that I should be able to, in the end of the day, promote human well-being, human agency, and equity, right? And that means in my world, in our world in the medical space, right? Am I saving and improving lives or not? Or am I doing more harm than good? Is my risk benefit ratio out of whack, right? Am I accurately and ensuring accessibility and including diversity and diverse perspectives and experiences? At SAS, we have a data ethics ambassador circle. We're actually ready to train our next cohort, where this is going to be part of an integral part of our work. Not only am I talking about my subject matter expertise in data management or in data analytics and in epidemiology, but also, am I doing it transparently? Am I doing it with accountability? And am I doing it with trustworthy AI? And then operating reliably and safely, and respecting the privacy and data of subjects, and being able to explain and instruct on the usage openly, including potential risks and limitations and how decisions are made, and then proactively identifying and mitigating adverse impacts. Very similar, you'll see, right, to the federal tenants. Well, guess what? We sit on the White House Advisory Committee, as well as in the EU, we work with many of the policymakers there as well. And so we're happy to be part of the discussion and the generation of these principles, because that's how committed we are. So one of the ways that the federal government has come up with how do you put this into practice is having this AI risk management framework based on the National Institute of Standards and Technology. If you're not familiar with NIST, I highly recommend and encourage you to go and do some more research on them and what those standards are. This is actually one of the ways that we are supporting it and implementing it. All of our software now has to meet these standards. The first one is framing risk, right? And that includes understanding what the potential issues can be and harms, and the challenges for AI risk management. So, and then the next thing is understanding your audience. Who could be using this? Who could be impacted by this? Who are we missing? Who's not at the table to ensure their participation and their protection? And identifying and managing all of the AI risks and potential impacts. Okay. Next is looking at the AI risks and trustworthiness. Now that I know the risks, how can I implement the trustworthy AI in a way that is responsive to a multiplicity of criteria and that area and that value of interest, right? And so how can I understand better without doing harm or doing minimal harm? And if there is harm, what is my mitigation strategy? And then looking at effectiveness of the AI risk management framework, right? And it describes the benefits for the users of that particular framework. And then looking at what that core might look like, the AI risk management framework core, it provides the outcomes and the actions that enable that dialogue, that understanding, and activities to manage and mitigate AI risks and responsibly develop trustworthy AI systems. And this is actually operationalized through 4 major functions. Can you govern? Can you map? Can you measure? And can you manage? And then finally, what those profiles are, right? The use case profiles are implementations of that AI risk management framework that has the functions, the categories, and the subcategories for specific settings or applications based on the requirements, the risk tolerance, and the resources of the framework user. These are principles that have been shared by NIST, and these are principles that we actually implement on every part of our platform in our development. If I put this button here, what am I mitigating? What am I encouraging? Where am I limited? Who is not going to have this access? And if you notice, if there are a lot of folks, for example, that use SaaS today that already have some impairments, right? Whether they're hearing impaired or if they are sight impaired, and we have accessibility features to help them still leverage our software. So let's talk about bias, right? Because this is a big deal for us. So aligning analytics with ethics, right? This is a while back, okay? So this is not something new for us. But in Target, this girl was pregnant, and the father, Target found out that she was pregnant before her father did, right? So it's very insensitive marketing, and it actually showed up in his feed, right? We understand that Medicare beneficiaries' race and ethnicity data are inaccurate. So here's another bias that you're introducing here is inaccurate data. We talked about this already, right? Bias models, right? Why Amazon's automated hiring tool discriminated against women because they trained the model. And this was well before ChatGPT, guys. Like if you look at this, this is 2018. Okay. This is older than 9 years ago. These articles are not new. So these issues are not new, okay? And so understanding that when Amazon decided to try to automate this using machine learning and AI, they trained the model on employees that they already had, which was already a bias towards men. And so any name that looked like a woman's name, even Pat, for example, right, would be thrown out even if they were a man because of the way the model was trained. And some of these other things, right? Profiling, mistrust, data decay, right? And this is where we're going to get into the fun stuff, right? When you do your analysis, when you deal with any data and you want to answer a question with research, this is generally the life cycle that you're going to go through. You have your question, okay? You're going to access, prepare, and govern your data. You have some data management. Then you go to developing your models, whatever kind of models they are. They could be predictive, they could be machine learning, deep learning, large language models, AI, whatever you want. And you're going to build and optimize and validate. And then when you do that, you will now deploy those insights. We don't just do science research because it's cool, right? I mean, yes, we're cool. Nerds rule the world, but it's not what we're doing here. We're doing this so that we can answer these questions, so we can further improving the patient's lives or saving their lives, right? And so you have to monitor and retrain data models many times because the data will change and then the model will decay over time. And then you make a decision. Where am I going to intervene on behalf of this patient? Am I going to be in a prevention mode? Am I going to be in a treatment mode or a curative mode? Or am I going to support for palliative care because they're at end of life? All the way, you have robust data governance, you have transparent AI, and you have secure model ops and processes. That is how the SAS Institute implements and supports trustworthy AI on a practical and implementation level. So what is trustworthy AI? Okay, very high level. I know that this entire day has been talking about this, but it's developing and using AI technology in an ethical manner. Do no harm, have no harm done. Ensuring that AI does not harm people, right? Asking not just could we, but should we, right? And this has been reiterated in every discussion that I've been a part of or that I've been a spectator of in the audience. Okay, building AI that reflects our values as a society. And it starts with the individual and it moves up to the group and the corporation and then the community and then the society. Right? So let's talk about bias, right? Because without AI, without bias, you have no discussion here. We've already known about bias for decades, by the way, right? That's what the whole science of epidemiology is on, right? Is how do I quantify these biases? There's over 126 biases that are documented, right? And we're still going to learn some more, right? Like hallucinations, for example, right? And so that's a new bias. And the way we deal with these biases and where they show up, right? They show up across the entire life cycle that I just went over with you. And identifying where those risks are, because the bias might then expose some things or put somebody at risk, and how we address it. So for example, if I disclose data, a person, a process, or system creates and publishes and shares the data. So I need to acquire the data, right? We do this every day, and we need to store the data. What does that acquisition look like? Is it an API? Is it a file share? Is it on-prem? Is it in the cloud? Is it in a public cloud or a private cloud? And then I need to be able to store these data. What kind of governance and firewalls do I have? What process do I have around it? And if you work with a privacy office, you know that they're very particular about especially health and medical data that could be compromised in any way, shape, or form, because there are accountability issues with the regulations and the policies that we have, right? There are penalties. Well, guess what? With all of these governance and data acquisitions issues, right, we have two biases that naturally show up. One of them is availability bias. Do I have the available data? Oh, wait, we talked about that in the challenges earlier in the slides. Or what about the recall bias, right? Is it subjective, right? We talked about those PROs, right? Do you remember when people were trying to get, some researchers were trying to get patients to be more active? So part of the regimen for CHF patients where they were supposed to play on the Wii. Okay, do you remember the Wii a while back when it was still white or red? And they had the movement controllers. Well, some people learned very quickly that if I put the controller on my dog, it's still moving, right? And so there is a recall bias there, right? And there is a bias in the kind of data that we're going to get in that actography through the gyroscope on the controller. Now let's go and stage and prepare the data, okay? Because now we got the data. And we all know 90% of our research is dedicated to data management and data prep. Okay, so we have now we move to a system transforms or moves or analyzes the data. We have pre-processing so it can become analytically ready, and then we're going to build the model, right? And so can I combine disparate data sets to create a larger data set that is greater than the sum of its parts? Well, guess what? There's a lot of restrictions around medical data that you cannot combine data. Well, do we have then a more comprehensive view, or do I risk re-identifying the patient, right? That's why you can't combine the data. Also, can I examine then and transform the data with the purpose of extracting information and associations and discovering new insights? Well, guess what? When you are developing these models, and that middle thing, that's the fun part. That's why we do what we do. You have a slew of biases. These are just some of the biases. Okay, there's a lot more that I did not include here, right? And there's also a need for bias sometimes. Not all bias is bad. An example, sickle cell, right? I don't want to find white women in my sickle cell study, right? If I do, then my data is not appropriate, and it's probably miscalculated or miscaptured. Right, and it's too dirty and the quality is not proper, right? So I can have exclusion bias. There could be pre-processing biases. There can be measurement biases or time interval or historical biases. You can also have confirmation bias or cause and effect bias or confounding or a collider bias, right? So anybody who works in real world evidence knows that you do propensity matching, right? Because that propensity score looks at the propensity for you to be assigned to one treatment group or another. It helps the balance, right? But you have selection biases in there, right? And chronological bias or immortality bias or hindsight or funding bias, right? And then let's go now to the consuming the data and the insights. When you deploy your model, right? When you're sharing and selling, or you're making a decision and you're going to dispose the data from the servers, right? Once you're done, where does that go when you hit delete, right? Is it recoverable, right? And is the governance compromised? And you have automation bias, deployment bias, drift bias, and reporting biases. Of course, all of these biases that I'm sharing are just examples. It's not a comprehensive list. There's so much more, right? And so sometimes, right, you want to be able to say, for example, even outside of our work, let's just say that a financial services company has a $1 billion pledge to provide capital to African American women to start small businesses. Okay, then wouldn't it be good to know when an African American woman is applying? That's an example of positive bias, a positive use of the bias, right? And they learn by definition from the data they are fed. So if you're looking at any kind of machine learning, and that's the basis of AI right now, that means that there's bias in the training data, means that there is bias in the output, right? And the previous speaker talked about garbage in, garbage out, right? There's a lot of things that we can look at where if you want to look at any of these individual biases, epidemiologists have quantified these biases decades ago. That's where we get the error bars from. So how can I use epidemiological methods to assess what bias is tolerable and how I'm going to quantify it, and then confounding that bias and compounding it? What kind of error and limitation now do I have in the interpretability of my results? Because really that's what's important at the end of the day. I have an insight here. What does that insight mean? Where's the so what here? And if I can't interpret it properly, then I run the risk of not being able to support the very population that I was out to support. I want to be mindful of time, so I'm going to quickly show you where on the platform, the VIA platform, specifically, we have incorporated these applications of trustworthy AI. These are methods or modules or dashboards or reports or analytics that support the execution of trustworthy AI, right? So and when we govern, okay, we talk about the quad here at SAS, right? You have oversight, right? And you have controls, you have platform, and you have culture. So one of the ways that we're influencing trustworthy AI is in our culture by having our data ethics ambassador circles, for example. So trustworthy AI isn't just, am I programming the right program? Or am I getting the right data? But it's my mindfulness of my beingness and where I'm actually applying my skill set and still considering beyond the numbers and beyond the program that I'm working. Okay, and then in the platform, so I'm going to go over our platform right now, how we support it in the platform and the modules, right? And then there's oversight. So we actually have an AI oversight committee. I actually have one of my partners, my potential partners right now, that is trying to work with me at SAS. They're going through the AI oversight committee review. Do they align to what we stand for at SAS? Okay, so for example, now we have our activation, okay, and we have our SOPs and the operations, right? But then I have a whole data management suite where I look at data quality, I look at variable metadata, I can prepare my data and still have a lineage and an audit trail of how I prepared it, and it's transparent, and I have a data asset catalog. When it comes to explanation of my data or the insights, I have natural language explanation, right? So if I'm running an analysis, there's a natural language generated explanation and interpretability of that model. So I can't just go, oh, I see a p-value, so therefore, no. We have scientists and mathematicians and statisticians who deliberately write, if you have this, then this, right? Because that's how this statistics needs to be interpreted. You have explainable machine learning. The FDA has our platform, our newest platform, because of the explainable AI and the transparency. You have counterfactual explanations, right? So if I did this, I can do a lot of what if scenarios. If I were to do this, this is what would have happened. I have surrogate model interpretation, and I have causal inference. So I can do directed acyclical graphs, for example, as an epidemiologist. Okay, beyond that, let's talk about in the technology detection. We have a bias detector. There's a button there that says click fairness and bias detection, and it will show you the performance of the module. There is a dashboard, and I hope I have a screenshot of it for you, that shows you this is what it looks like through a racial breakdown, this is what it looks like through a gender breakdown, and this is what it looks like through an age breakdown. Those are just some of the demographics that we have. You can extend that to anything else, right? National versus a resident. You can look at it through rural versus urban. You can look at, there's the possibilities here are endless, but we have the breadcrumbs to do it. And then you have that fairness assessment. Is this a fair model? We found out that you were able to detect, based on your pulse oximeter, whether a patient was Black or white, because it would actually be a lower reading because of the melanin in the skin, and the pulse oxes are not accounting for the melanin in the skin. So it's actually giving, on average, African Americans and black folks a lower pulse ox reading. Right? We know that now this is the limitation of that particular device. It's not like, oh, African Americans run on average lower. No, we're detecting it lower, right? And we want to be very mindful of how that's interpreted. Again, because of the impact that it can have. And then privacy and security. Can I preserve your privacy? Yes, we have a lot of encryption. We have model security. We have autonomy of preservation and consent and control, right? And our environment manager has very, very high restrictions if you need it, even down to the cell level in the data table to be encrypted, or not even accessed or seen by a member of the team if you need to limit that. Now, mitigation, we talked about risk mitigation. We have bias mitigation, we have bias prevention, and we have synthetic data generation. Now, in healthcare, synthetic data is a little tricky, right? The jury is still out. Nobody's perfected that process, but there are some pretty decent examples out there. They're just missing a few things, right? So like Synthia data, for example, or SynthIO, they try really hard to do justice to synthetic data in healthcare. We're just an anomaly, and it's a hard thing to sell because we don't have access to instrumental variables. For example, like Synthia, when they actually built it in R, which is fine, they actually ran an opioid scenario for that synthetic data generation with the outcomes without Narcan, because that algorithm happened to be developed before Narcan. Well, guess what? Nobody's actually updated it. So when you generate this the synthetic data on an opioid abuse scenario, you're going to miss a very major key component of the entire discipline, which is Narcan. Right. And of course, then there's limitations, like they don't have behavioral health services linked into the algorithm. So that's not even part of it. Right. So rehab and mental health services are not even part of it. Right. And then finally, model ops. Right. We're getting model scorecards. I ran a model, and I want to know what the health of that model is, the robustness of the model, where the bias is, and how fit that model is. That's a scorecard, right? That's available in a dashboard. Decisioning and lifecycle management and metric monitoring, and model robustness and model oversight are all in our model ops, right? So let's go back to this. Remember that last quadrant that I showed you, right, is all here. This is when the rubber meets the road, right? You're really going to never know what the bugs are or how applicable it is until you actually hit it, right? And so you're deploying it, and you're like, oh, wait, there's something off here. right? And that's what we found in financial lending. That's what we found in the justice system, right? And SAS is trying to right those wrongs now with our Trustworthy AI, with all of those business units. So we're very heavily involved with the government to be able to, especially with the Office of Minority Health, and the Office of the Department of Justice, to make sure that the biases that we're finding are either leveraged in a positive way, for mitigation or redemption, or recompensation, or they're prevented altogether. So how do we do this? We talked about this a little more, right? You have to have trustworthy decisions, and they depend on good data. And so again, on our platform, you have data quality, data exploration, information privacy, data masking, data suppression, data lineage, and synthetic data. And I'm going to go through these pretty quickly, but you'll have access to these slides afterwards. I'll be sure to share them with the organizers, right? So you have in the SAS platform, and this is an actual screenshot, it's not doctored, right? Where you can automatically look at column analyses to alert users to potential data quality issues. You'll see a distribution of all of the data sets and how that looks, where the null values are, where the uniqueness is. If I'm doing gender and I am expecting 5 categories and I have 10, it tells me I need to go look at that data point and the quality is compromised, right? So you're looking at completeness, correlation variables, mismatched values, and outliers. Also, then in the data exploration, I can immediately look and understand the variables in my data. So I can quickly determine what that looks like, where, especially if I have data that's being delivered over and over and over again. So it's not one static data set, but it's actually, that has snapshots, right? And it's being delivered over time. I can see differences over time in medical claims, and medical EMR. I mean, patients don't stop coming, right? I continue to grow. I wish I could put myself in a time capsule sometimes, but I don't. And so as I can continue to grow and transform and evolve, so will my data, and that should be able to capture. You should be able to capture that at an individual level as well as a population level. Assess marginal and conditional data distributions. Is there an outlier? Why is there an outlier? What's going on? Do I do some asymptotic trimming, or is there a bad data point in there that I need to go back to the source and fix? Identifying suspicious anomalies. Is there some fraud here? Or is there some carelessness or sloppiness in my data? And then explore natural groupings, right, existing in the data, right? And then looking at information privacy, we automatically identify potentially private information data assets. Hey, by the way, when I profiled your data, I found these things that could help possibly identify a patient or be a name or be part of the PHI or PII, right? And they'll actually flag it as sensitive, private, or a candidate for. And then age, gender, and location, for example, are some of the things that we do. We keep the human in the loop on purpose. And so can you come and review this? Then looking at data masking, we can anonymize and mask the data in selected columns. And it's a method of hiding sensitive information, and it's or personally identifiable information, PII. We can do this, and it meets all of the privacy regulations right now, including GDPR. And then data suppression, I can suppress values if you don't need to see it. So Social Security, you're never going to see that. And I can hide them, and it will not compromise the integrity of the data. Data lineage shows you the assets, who did it, when they did it, why they did it, what is linked to that data and the actions, and then any pipelines or any transparency of analytics that was done on it. We actually have turned this into an audit trail for one of the financial sector banks, because they wanted to be able to do an audit trail that includes, and we're also talking to the FDA about what an audit trail would look like for them as well. So quickly go with risks and rewards, right? The natural language insights, model interpretability, and fairness and assessment. And I'm probably going to stop after this next set of slides so that I can save some time for questions. But we automatically generate graphical insights about the data in the models. That is our model. This is what I was talking about when I said natural language generated interpretation. So here is the breakdown. This is what this means based on the models that were run in the tournament. And this is automated explanation. So here, what is the characteristics of customer satisfaction? Or you can say patient satisfaction here, right? And well, we got 1 to 5. The average customer satisfaction was this. This is what it means. And by the way, when you're higher or lower than the median, this is where we found the breakdown. And so, for example, we'll say that the customer or the patient state of Georgia, Kansas, Maryland, North Carolina, or Texas usually had a less than a median score, right? And that there were 11 cases, and they can break this down very easily. There's no programming involved here. It's all point and click, drag and drop, so that you can generate these insights easily. And we are taking on the liability of the accuracy of these insights. Model interpretability, right? So for example, you have partial dependence plots, individual conditional expectation plots, local interpretable model agnostic explanations, and kernel shapely values all are in here. And if you look hard enough, you can see the node, the assessment, the model interpretability, and right next to it is fairness and bias, right? And that takes us to our next slide. Here is the breakdown. If I run a machine learning or AI algorithm on SAS, I immediately have this generated. I don't have to say I want this option. It is without the option of being optional, right? So automatically everything will actually be determined, right? So here we're looking at race, right? You can look at, and you can actually run this by any of the variables that you choose, but the default will always look for race, gender, as well as age. So you can detect bias and reduce bias using the exponentiated gradient reduction algorithm. In predictive modeling, for example, bias occurs when a model's prediction or performance differs across groups. So it's different against, say, Caucasian, African American, and other, or Asian. And then, for example, if you're looking at a loan engine, right, and it favors a particular gender over others, or a particular race, or any other subgroup of patients, right, or a subgroup of individuals, you're able to actually identify that. I'm going to pause here. That gives you 8 minutes for some questions, but the slides that you'll have access to afterwards are looking at model operations and deploying those models and what that process looks like. So for example, here is the model scorecard and the governance, and it shows you which variables stay in or fall out in the decay or the change of the performance of the model as it evolves. You can monitor models that are in performance, especially in the financial sector, or as we get closer to software as a medical device, what kind of patient you get will may be impacted by an algorithm or impact the algorithm. And then looking at decisions and accountability. Actually, I'm just going to go ahead and finish this because I'm actually at my last 2 slides, right? And then finally, the key takeaways, right? We know that AI, we've already talked about this, is here to stay. It affects every single industry, every single person. All of us are impacted by AI on a regular basis. And we also know that doing the right thing is good for society and good for business, as well as protects the individual. We know this because even the federal governments across the world have now implemented regulations to honor this. You have to prepare for regulations, right? So you enact your principles now because regulations are coming. Even though they're not finite, we always know that the science always supersedes and happens faster than the regulations can keep up. AI equals risks and rewards. Be objective and transparent about both, and you will have mitigated most of the harm that can be done. Trustworthy AI requires a comprehensive approach. So you must have your SOPs, you must have your oversight and your governance, as well as the technology and the culture. The culture of your organization must be bought into and trained on trustworthy AI. And then we support it across the entire analytics lifecycle, and that's our technology, and we're very proud of that. There are some more things about responsible innovation at SAS, specifically if you're interested, or what a trustworthy AI might look like through our ebook. And then we have blogs galore. I'm happy to share website links afterwards as well. And then if you want, there's a QR code there that you can scan. You can connect with me on LinkedIn. I'm very excited to have that connection with you. And then if you want to learn more specifically about responsible innovation at SAS, feel free to scan the second QR code to the right. It will take you to our Trustworthy AI and Responsible Innovation website. Thank you for your time today. So that gives you 5 minutes.
Wonderful, Sherrine, very interesting talk. So I have a lot of questions for you, but just go briefly. First of all, like as you have shown some of the demonstrations, how SAS is being used to identify, mitigate bias, and that's all automated. Is that available on the academic version of the software, like SAS Studio, or we have to take the license for that?
I will have to get back to you on that. I believe on SAS Via for learners, it's available.
Okay.
I can get back to you via email, and you can share with the attendees where exactly. I know for sure it's on Via, and I believe it's on Via for learners. I don't
Okay.
believe it's on SAS 9 right now.
Okay, because it will be great if we can show our students with
Absolutely.
some kind of a demonstration with the data sets, and
Mhm.
that will be a really great addition. So going into the one of my question is like if we compare industry research and the academic research, let's say on the trustworthy AI.
Right.
So industry has variety of teams, and like each team is basically handling a part of the whole pipeline, right? And let's say like I am a student or I am a researcher in machine learning. So the most of the time that I am spending is basically on finding ways to like to get the optimum model, get the results, and optimize that model, like building like innovation in that area, right? So this part of like the bias part, mitigating or identification, is basically being excluded because I am morely focused on the modeling side, right? And that's what I see in most of the data scientists. So what do you suggest, like in an academic research, if a student is working on data science research, then how will these components can be incorporated in their day-to-day life? Yeah.
There's one of two ways that you can approach this. So if you're going to go through the assembly line type of approach where I'm hyper focused on this part of the whole cycle, okay, then make sure that what you are doing and the technology that you are using is implementing the trustworthy AI components or principles that you can do, right? So even if you're programming in Python, for example, as a data scientist, there are some principles that you can actually look for. Now, you might have to do them manually because they're not available to you in Python, but you might, when you do them manually, you'll understand how to extract or at least assess your studies, right? Or your methods. But you can also then, I think that the data scientists of today, tomorrow, have to be at least well versed in the entire life cycle. We can't afford to be hyper specialized in only one approach, because remember, I just showed you there are so many biases that they will compound, and by the end of the day, you might have so much error that your study is worthless.
That's true. Yeah.
Right. So responsibility on my part is, as the data scientist, I work with the epidemiologist who works with the statistician, who works with the clinician, who works with the data provider to make sure that there's not too many compromises along my path, so that when I'm actually implementing my data science, for example, I'm taking all of the necessary precautions to assess, right? So for example, in epi, we're very good about doing sensitivity analyses because we want to know, well, I'm not so sure. So let me keep this group in and then take them out and rerun the same analysis. Do I get a different result?
Yeah.
Right.
Yeah.
So
Yeah.
data scientists today are not trained on that, unfortunately. Right.
Yes.
But that's an epi. So taking a very multidisciplinary approach will probably be the safest and the most responsible way to go about this. Now, the nice thing about SAS Via, as opposed to like say SAS 9, is that it is a full comprehensive platform. So the person who is working on the data management piece may very well be somebody who's different than doing this data science piece, but I can see across, and the platform is easy to navigate. And I can say, okay, I'm going to start working on my piece, but before I do, let me go back and see what the data managers did. And when I
Yeah.
do that, it's easy for me to say, okay, now I can start assessing or adjusting. Maybe I don't include this in my propensity score. Maybe I stratify in my analysis, and that's going to be a priori, right? So it's not ad hoc analysis anymore. Now it's a priori. And also a priori, I'm going to put in my statistical analysis plan that I'm going to do a sensitivity analysis because I know what kind of data is coming through my pipe. I'm not going to negate the data, but now I have to compensate for the quality of the data just because of the inherent nature of how it's captured by doing some more analyses to really truly tell you without a shadow of a doubt, this is the truth that I can come up with the data that I have.
Okay, so basically, a key learning that I have from this talk is like we also have to be as an educator when we are training the data scientist, we have to let them aware of whenever you're working with the project, you have to take care of these components at each stage of your pipeline, not just like focusing more on like the model building or innovation on that side, but have to consider these aspects of trustworthy AI because they are not aware of it and they think like, okay, model building is the most crucial step in any data science project.
By the time it gets to model building,
Yeah.
they take for granted all of the 80% of the work that was done. And so that actually will influence the validity of the models that they build. I mean, model building is very complex, but like the best epidemiologists that I've ever met are also dually trained in biostatistics. Right? And the best biostatisticians that I've ever met are dually trained in epidemiology because it is an art between study design and analytics and then the appropriate analytics and the math that goes in it. Right? And so for a data scientist, the best data scientists are going to have some understanding of domain, some understanding of data management, and some understanding of data capture. Like, how did I get this data in the first place so that when I run my model, I understand what I'm interpreting?
Yes. Yeah, okay, that's wonderful. And we I just started a small project with our students, and I found that there is a paper in which the authors have found racial biases. I think the previous speaker has mentioned in a very proprietary algorithm for the risk scoring.
Yes.
And we reanalyzed it, and we found there are more biases even on the initial stage with just a simple visualization in the starting point. And we found like, although it is like published from many, many years, but the authors have found racial bias. We found some more biases in the same data, like not just on the data, on the algorithmic side too.
Yeah. So remember, epidemiology, and I am biased here, okay? But epidemiology is the study of disease patterns, right? And in Epi 101, the first thing that all of my professors used to tell me, and I'm not going to tell you how long ago this was, but it was many moons ago. The first thing is visualize your data and understand your data. Right? Run a scatter plot or look at a histogram. I know it sounds really simple, okay, but it's very quickly interpretable when you have a histogram that looks like this versus a histogram that's in the middle, all right, that's skewed one way or another, or to see the clustering of in your scatter plot up here when in fact you have some outliers here. So you either have to look back or understand or try to better understand, because they would never let us do any kind of analytics, anything predictive or otherwise, until we did our descriptives first.
True. That is the really most critical part whenever we start any analysis. So I have another question, and then we'll go with the audience. So you said that in the deployment stage, we need to monitor the model. So what should be the frequency of monitoring? Because in general setting, it is not easy to monitor the model very frequently. So what should be the frequency of that monitoring the model after deployment?
Many folks are not going to like my answer, but it really depends. And it's mostly dependent on how frequently your data is refreshed.
Okay.
And so I would, especially if you have different frequencies of like, let's just say you integrated data sets together, right? And they all refresh at different intervals. One might be weekly, one might be daily, and one might be monthly. Okay. And I would understand the rate of refresh and the rate of change within those refreshes. So if, for example, that daily update data set has significant changes, then I would monitor daily. If it
Okay.
doesn't, but the weekly has significant changes, then I will lessen my burden, because we're also here in productivity, right? I would lessen my burden and monitor it weekly. If those two don't have significant changes, but you can actually get away with monthly, then go ahead. But it really does depend and is determined by the rate of change and the rate of refresh of those data, because remember, machine learning algorithms learn on the data, right?
Yeah.
And you can also set it up where it's automated. I mean, you can set it up at SAS that it's automated and you're actually alerted when there's a change in the model. So if you don't want to manually go in and check, there is a way that you can automate that check for you.
That's
And that
true. That's true. Yeah.
yeah,
Because as a part of my PhD, I was basically working on stream analytics frameworks, which basically not like storing a data somewhere and build a model, but analyze it and monitor it continuously. So I
exactly.
think in that pipeline, if we can incorporate some of these concepts, that will be like a real-time monitoring of the
Yeah.
data all the time. But it's really tough. It's not that.
No, and
Um,
it's
yeah.
labor intensive and it's resource intensive. So that's
Yeah.
why you're preparing students to go out into the industries, right?
Yes. Yeah.
And still do right by the business. It's not
Hmm.
really feasible to do a minute by minute
That's true. That's true.
review, right?
Yeah.
And assessment. So if you're monitoring it wherever you can automate and you can keep the human in the loop responsibly and reasonably, go ahead
Yes.
and do that. But I mean, in an ideal world, it would cost nothing to do it. And then yes, absolutely, every time you have the rate of change. But I would go by the heaviest weighted data, meaning that it has the most significant change and its frequency of change, and then set the automations for that.
Great. Okay. Thank you very much, Sherrine. Is there any question from the audience? I
I
think there
see
is a big one.
Lonnie has one here. How can we
Okay.
ensure?
It might be a little bit much to read, so I'll just ask it verbally.
Sure.
So what I wanted to know is, were you able to find anything on how we can ensure data privacy or any regulations that we could follow for people who use some of these common tools? Because
Mm-hmm.
our world is kind of now a little bit more integrated. So
Yeah.
we use our smartphones, our credit cards, and stuff to pay for stuff.
Yep.
One of the examples I've come across is that a lot of these technologies and devices kind of force certain protocols in
Mm-hmm.
order for the device to function.
Yep.
And an example of that is like if you go to the doctor's office to pay for something, and that doctor's office uses Clover. Well,
Mm-hmm.
Clover is a cloud platform with an integrated network. And let's say fast food restaurant A is in that network. Well,
Yep.
now fast food restaurant A has your information and they have an agreement with marketing company B to data share information back and forth. So
Yep.
now company B has your information and they can do whatever they want with it. There's no clause
Mm-hmm.
directly tying them down to a certain
Mm-hmm.
ethic. So now you're open to all types of unsolicited mail, any discriminatory processes, or anything that would identify you based off of just you using your credit card or your bank card to pay for a service at a doctor's office.
Yep. And that's a today thing, right? What if you're, say, a kidney patient, right? You're going through dialysis and you're on that network, and now fast food restaurant A has your information. They solicit you. So now they're putting undue pressure on you. Okay. And then I was like, hey, come and get your Big Mac or whatever you're getting. Okay. Get your hamburger sandwich. And you're not supposed to have that. You're not supposed to have the sandwich or any of those processed foods because it's not a high quality protein. Then you can actually go ahead and you'll have that Big Mac or whatever you're going to have. You've now compromised your health, and you might not be a candidate for tomorrow's dialysis as a result because your numbers are off, right? And so
And that information is shared with like an insurance company, and
Exactly.
now that we're getting your payment, like how much you would pay is determined based off of that. So it's kind of like all connected. So how can we ensure, or what type of regulations can we leverage to keep software and device technologies from including that as a measure of using their devices?
So this is Lonnie. I would encourage you and everybody that you know, and everyone on this call, to start looking at NIST practices and the federal tenets of ethics, because that's harm, right? And that's not respecting the privacy, and influence regulation and accountability, and that means penalties, maybe, that are strong enough and influential enough to bring about the change that you're looking for. It's very unfortunate right now that the regulations could not prevent something like that from happening. And we're relying on corporate policies and corporate citizenry. So are you being a good corporate citizen, and being true by not applying harm? We don't know that for sure. There's, you might say it, but what's the accountability there, unless there's a lawsuit or something like that? I would definitely, we have some breadcrumbs of tenets and guidances and practices, like NIST, for example, and the Federal Data Ethics Strategy, and tenets and the benefits of having ethics. I would take those and combine them and say, okay, now in a practical way, how are these being honored and practiced and executed? And where is there missing a safeguard? Because that's what we're missing right now, is the safeguard. And the safeguard here is accountability and action if somebody's found accountable and irresponsibly innovating, right? And it has to be a swarm of people. It has to be not just an individual, but it has to be probably a collaboration, a coalition of some kind that is savvy enough to understand and interpret the regulations and then demand more.
Thank you.
Wonderful, Sherrine. It was a really interesting session, and Laurie has also joined. Thank you, Laurie, for making this happen in our workshop. And definitely, we will be in connection to see if we can invite you in some of our ethics classes or some of the things that will be beneficial for our students in the future. Yeah, thank you very much, Sherrine and Laurie. Yeah.
It was a true pleasure speaking with you guys today, and I hope you found it beneficial. And again, feel free to reach out to Lori or myself. Use the links that I provided. That we as a corporation are very passionate about this.
Thank you.